Just begin by adding a correction to the last one. I said that I can't remember the wording that I didn't know of any other way to determine this to determine whether or not something had been further derived from my class. Forget it was base star. Yes, something like that. And this turned out, this here turned out to be not null. And I said I didn't know of any other way to test whether or not this was further derived. Well, the part that's incorrect there. Part of what I said was correct. Dynamic cast will not tell you that if it's further derived. That's true. But saying that I didn't know of any other way to do that happens to be incorrect. I'd forgotten that there is a way, in fact, to make this test to see if it's something that's further derived. That is, if this comes out non-null. And I even have a macro for it that I've used for ages, and that's this. This type ID thing has a double equals operator, so that's another way you could tell. But that doesn't mean I've got type EQ. The equivalent code would be something like this. Something like that. And then that would work in a similar way, in fact. I wonder if that was what that function was called. I guess it was. So this should print out, well, hang on a sec. Okay. I just want to make sure that you don't see what I'm setting it to. It's got to be a secret or it's just no fun. Okay, here's a derived and not same. Okay, and PD is the classy derivation. D being just a derived. Oh, it doesn't say that. Now, that's okay. That's not so bad. Except for there is this problem. I wonder what's the best way to show it. So all these RTTI things have this problem. Okay, I gotta pause and make a secret change. Okay, the secret change is made. Now I'm gonna run through this code again. And I'll simply step over this line and oops, it crashed. How could it crash? Nothing wrong with that pointer. It's a perfectly good pointer. Crashing there. Hang on a sec. Oh, I know. Just a minute. Okay, I don't know. I guess I just stepped to this line or something. Yeah. All of these dynamic cast things will throw an exception if it's not a polymorphic type. So there's that. Although you'll notice that this is a special kind of exception, and it's one that you can handle pretty easily. although it's triggered by an access violation. The idea of using an exception for flow control in your program is, well, I suppose it's fine, but if you can avoid it, I think avoiding those sorts of things is preferable. I mean, the equivalent code that doesn't crash is where is it now? Here. I'll make that away, and that's true of this type equals as well. It'll crash. Okay, now PB comes back not null. And but this comparison is okay. It doesn't crash the system. They're not the same, right? One's not even a polymorphic type, turns out. If this is null, of course, you wouldn't compare. Now, what have I returned here? Now I can show you. I just returned malloc of 10. Okay, so it's certainly safe for me to check that. What if I returned malloc of 1 or something, right? Is that going to cause an access violation? Well, the answer to that question probably depends on whether or not it's a debug version or a release version, but it's doubtful that you're going to get an access violation. Certainly in the debug mode, where is PB, am I going to get in the debug mode, there's always 8 extra bytes added for every allocation, these FDs here, 4 on either side, and that allows the mallocing and unmallocing freeing code to check for an overwrite or a spill or something. At the end, it checks to see that this has not been changed, and if it has been changed, it can say that you made a mistake. The memory got corrupted, but that memory is readable. What if I returned something that is like the example here? Just cast that as a base, so that you know that this memory is not writable. What about reading it? Reading it should be okay. We're okay, no crashing. Okay, so well, I think there's some utility to the fact that you don't need to throw a processor fault in order to determine if something's the same. This is far less likely to be a crash, and it does come up. It does provide you with this answer, right? It does provide you with the same information in the cases where this thing is of exactly the same type. It won't go in here. The other advantage to knowing about the implementation thing and like about these vtables and that is that you can do this when they aren't the same. Okay, and you're willing to take a chance on dynamic cast, so we'll go back to the classy, get rid of that. Now, so we need dynamic cast. I'm amazed I got back there. So in all truth, this cast here should be surrounded by a try, and then a catch. No, it's a C++ exception, and there's a special format for these types of exceptions, and I think it's just exception. And if that does happen to go off, if this does cause a crash, instead of the system crashing, it'll go in here, and you can print out that, and it'll give you a little description about the crash. Okay, dynamic cast or type any RTTI, you have to put that surrounding code. Okay. Alright. That's a PD. They're not the same type. However, they're of similar type. And one thing you could do is find out if the number of virtual functions has changed, and that one happens to have one extra function. Now, given what we know, even though we don't know anything about that function, we could use this call vfunc of I think it had 6, so 5 is valid. If it's a great big project and you don't know where this class is or what it's added, you could just step into it slightly. Oops. Okay, get down to the call, and then you found the new function, and here's the definition of the class, and so that could be useful. You could also, in theory, not in theory, and easily in practice, you could compare your table with its table and see if it's overridden any of your functions. And that might be of some use. Who knows?